Hi guys, so we're gonna go back just a second, if I can find it, because I didn't feel like I did a great job of talking about projection. So let me open that just one second, and we're gonna talk about the types of projection. Just one second again. You can skip it if you feel like you get it. But so so most maps that are in books are called equal area projections, and that type of projection. The benefit of that is that the relative sizes of the land masses of the maps are the same as in reality. So, if something looks larger, if one area looks larger than another area, then in reality, that's what it's going to be. And those projections minimize the distortion in the shapes of most land masses. So areas in the north, toward the north and south poles, such as Greenland and Australia, are going to become more distorted, however, because clearly they are going to be up closer to the top of the globe, and that area has to be spread out. So like a little mouse. Okay, so this area up here and down here is going to be more spread out, and this is going to be more distorted. But because they're sparsely inhabited, generally it's considered not as important that those are distorted. So So to preserve the size and shape of land masses, there are other projections that center, that try to create other types of distortions. So when the eastern and western hemispheres are separated into two pieces, this is a characteristic known as interruption. So interruption is when the eastern and western hemisphere are separated into two pieces. The meridians, which are the vertical lines, in reality converge at the north and south poles, do not converge at all on the map. Also, they do not form right angles with the parallels, which are the horizontal lines. The Robinson projection, which is this one right here, the Robinson projection, is useful for displaying information across the oceans. Its major disadvantage is that by allocating space to the oceans, the land areas are much smaller than on interpreted maps of the same size. The Mercator projection, which is this one right here, has several advantages. Shape is distorted very little, direction is consistent, and the map is rectangular. Its greatest disadvantage is that relative size is grossly distorted toward the poles, as we talked about in the North Pole, in the South Pole. So that size is grossly distorted toward the poles, making high latitude places look much larger than they actually are. Okay, so now I feel a little bit better about taking us toward the next place. We talked about meridians and parallels. Okay, so this is where we left off, having just spoken about meridians and parallels. So here's our graphic for that. So once again, meridians are the part of the grid that go from the north to the South Pole. So the North Pole where Santa lives, to the South Pole where the penguins live. And the meridian that marks 0 is the prime meridian. There he is right there, the prime meridian. Okay, 0. And the meridians go from 0 to the east, 10 degrees each meridian, and to the west, 10 degrees each meridian, up to 180 degrees. And these are the lines of longitude. And so you're going to think they go long. They're long lines from the north to the south. Okay, and then we have the lines of latitude, which are the parallels, and they are start at the equator. Here's the equator, which goes through Ecuador. Think about Easter Island over here. Anyway, so Ecuador, 0, and they're going to go north 10 degrees each up to 90 degrees, and they're going to go south 10 degrees each, so 90 degrees north, and then they're going to go south 10 degrees each to 90 degrees south. Okay. And so the latitude, I always think flat or lines on a ladder. So latitude. You guys probably have those memorized, no big deal. And so lines of longitude, there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Obviously, 18, 180 degrees, and then 18 in that direction as well. Make sure that's right. Yeah. Okay. And then line there. Okay, now let's talk about time zones. Okay, so time zones. Let me click. Oh, hold on. Let's talk about this for a minute. Okay, so points on the Earth's surface can be communicated by referencing points of longitude and latitude. So Denver, Colorado's location is 40 degrees north latitude and 100 degrees west longitude. This is the absolute location. Further accuracy can be achieved by dividing each degree into 60 minutes and each minute into 60 seconds. So some of you, when you did the absolute location of your cities, you may have subdivided into minutes and seconds. Generally, when you look things up on the internet and ask for the absolute location, it will tell you the longitude and latitude down to the second. So if you look up Denver, Colorado State Capitol Building, it will tell you that it is found at 39 degrees, 42 minutes, and 2 seconds north latitude, and 104 degrees, 59 minutes, and 4 seconds west longitude. So the Earth as a sphere is divided into 360 degrees of longitude. Divide 360 degrees by 24 time zones, one for each hour of the day, and that equals 15 degrees per time zone. So each 15-degree band of longitude is assigned to a standard time zone. Oh, although did you hear recently that North Korea has created its own time zone, which is like a half an hour off because they don't want to be in the same time zone as Japan, because Japan was an imperialistic power and controlled them, and so they're like, we're going to be a different time zone now. It's totally reasonable. So then we have Greenwich Mean Time, GMT, and this is also known as Universal Time, or UT, and this is the time at the prime meridian, which is 0 degrees longitude. This is master reference time for all points on Earth. So this passes through the Royal Observatory at Greenwich, England, master reference time for all points on Earth. And there's an international agreement which says this is the master reference time. So everybody checks in there. Okay, the international date line, we're going to look at a map in just a second. The international date line is located at 180 degrees longitude. And the position deviates from 180 degrees longitude at times to accommodate various nearby nation states. So this is the point where you move the clock back 24 hours one day if you're heading east toward the United States or to America. Sorry, I don't want to be America's or United States centric there. And the point you move the clock ahead 24 hours one day if you're heading westward toward Asia. This is pretty complicated. If any of you all have traveled and crossed the international date line, you should definitely share that with us and share your experiences of how that went. I've never done that, and I would love to know how that went. Like, if any of you went to Japan by going west and crossing the international date line, or Australia, China, somewhere like that, Middle East maybe. I would love to know how that went and your experience of crossing the international date line. So adding a day and then coming back and subtracting a day. I think that would be really cool to hear about. So, for example, let's see, in Russia, oh, let's look at the map so you can see. So in in Russia over here, you know, they don't say like, oh, this chunk right here, you guys are a different day. You know, they let them say you guys are all the same day here. Because that would be really confusing if they were like, oh, Bob next door, you know, he's tomorrow, or I guess it would be yesterday. That would be really awkward. And then looks like this is a group of, yeah, these, you know, various groups of islands. So don't say like, well, on that island in Samoa, it's yesterday. Or, you know, Auckland, parts of Auckland. Yeah, so it would be really confusing, which is kind of the International Dateline people. So, okay, so what you do is as you go west to east, okay, as you go west to east, I'm reading the directions here. I lost my place. As you go west to east, you add 1 hour for each time zone. When you return to your starting point, you will reach the absurd conclusion that it is 24 hours later in your locality than it really is. Therefore, if it is 6:32 a.m. Monday in Auckland, okay, so let's be in Auckland. If it is 6:32 Monday in Auckland, as it is, then when you get to Honolulu, it will be 8:32 a.m. Sunday. There we go. Because the international dateline lies between Auckland and Honolulu. So not only do you cross a day, where's my mouse? Not only do you cross the dateline here, but you also cross 2 time zones. So you change from Monday to Sunday and 6 to 7 to 8, 2 time zones. So those of you who are extensive travelers, you have experienced this. I generally only travel from this time zone to this time zone because this is where my nieces live. Now I have been to this time zone and this time zone. I'm going to pause a minute because Larry's going to come in to clean my room. That will be awkward for everyone.